Hello, sir. Can you hear me?
Yeah, I can hear you loud and
Yeah.
clear. Last day we were talking about extrema of functions, maxima, minima. So, do you have any doubts from last time?
No. Like I was recapitulating through the NCRT also, so I got it.
Okay, good. So we'll do something which is a bit, which is not usually mentioned in usual books, which is sometimes the tests we set for maxima and minima, which were look at the first derivative, then look at the second derivative, and then you decide. That stops working. See, we had seen cases where it stops working, where we had the inflection point, but that's not all. So what we saw is if f prime x is 0, then it could be one of three things: maxima, minima, or an inflection point. How did you decide? We looked at the second derivative, f double prime x.
We'll find a second derivative, and then we can try if it is maximum or minimum.
Exactly. So second derivative, if it was 0, then we said it's inflection point. If it is positive, we said it's minima. If it is negative, we said it's maxima. But not always does this 0 imply that it's an inflection point. We'll look at that today. Sometimes this 0 also implies that it could be a maxima or minima. Now let's look at a specific function, which is fx equals to x to the power 4. Now this function, this looks something like this. Okay, this is fx equals to x to the power 4. So we can clearly see that it has got a minima at x equals to 0. Let's see what the derivatives take.
Yes.
Take the first derivative, 4x cubed. Second derivative. So first derivative set to 0 would give you the extrema. So x comes out to be 0. So there is something at x equals to 0. Now let's do the second derivative test. What is this at x equals to 0? This is 4 3 are 12 x squared at x equals to 0. This is 0. So we would think that this is an inflection point. But then we cannot stop here. If it's 0, we have to go to the higher derivative, f triple prime x. How much is that? It's 12 to the 24 x. Again put x equals to 0. What do we get? Again 0. Which means we have to go to the next higher derivative. So instead of giving dashes, we usually write the number on top of here. It means the same thing. How much is this? This is 24. So finally we get an answer 24, which means
It is a minima point
it's a minima. How did we decide? So see,
because the sign is positive.
sign is positive. But what if we would have got 24 in the third step? Then we could not have said that it's a minima.
Yeah. Then we could not say it is what.
Yes. So always remember this. If you get a number which is other than 0 at an even step, so 4 is even number. So at an even step, if it is even and you get a positive number, even positive tells you it's a minima. Even negative tells you it's a maxima. And if you get any number at an odd stage, then either positive or negative, doesn't matter, it's an inflection point. So now you have to keep taking derivatives as long as you reach a non-zero number. And then if you reach the non-zero number at an even stage, Then you can further look at the sign of the number and tell whether it's a maximum or minimum. And if you reach this number at an odd stage, non-zero number, then it's always an inflection point. So this is the general rule. Today we'll be mostly going through problems. X squared plus 1 by x squared. Let us see what the extrema of this function is. In the range x to the whole real range. X belongs to R. So you first of all take the first derivative. You get 2x minus 2 by x cube, and you set this to 0 to find the points of extrema. So you take 2x out, you get 1 minus 1 by x to the 4. This is 0. So either you get x equals to 0, or you get x to the 4 equals to 1, or x equals to 1. X equals to plus minus 1, right? So which of them is it?
The first options, x to the x 4 derivative equals to 1.
Right. So let's take a derivative and see. This is 2 minus 6 by x squared. You put in the values. You see, if you cannot put in this x equals to 0 value, it gives you an undefined number because you've got x here at the bottom.
Yeah.
So you put in these two values, plus minus 1. What you get is 2 plus 6, which is 8. So for both values, you see, it's 8. Because there's a square, you put minus 1, you get the same value. Minus 1 squared, it's also 1. Which means it's a minimum at both these points. So how does this look, function look? X squared plus 1 by x squared. How does x squared look? X squared, we know it's a parabola looking up, something like so, but it should pass through 0, 0. So this is the x squared parabola. And what about 1 by x squared? See, you put in small values of x, you get high values out in 1 by x squared. But if you put very, very large values, you get a very small value of 1 by x squared. So you can imagine the graph will be something like this. No? At small values of x, it's a large value. At large values of x, it's a small value. And doesn't matter whether it's positive or negative because you've got a square at the bottom. And the square will remove the sign. So you've got symmetric curves on both sides. You put plus x, you get the same value. You put minus x, you get the same value. So this curve will be repeated on both sides. Okay. So the entire thing, if you add these two, you'll get a curve that looks like this. And why do these minimas occur? We just now we said what these minimas are. We said there are minus 1 and plus 1. So maximum minimas also help you visualize curves. Okay. Let's go to the next example. Find the maximum value of 1 by x whole to the x. How do we do this? So this is a bit hatke from the usual things because you cannot simply take a derivative. You don't know what the derivative of this thing is.
Yeah.
The way to do this is to use monotonic. What are monotonic functions? We just learned monotonic functions last time.
Monotonic in which the function is strictly increasing or decreasing.
Or strictly decreasing. So say, tell me something. If I take this function fx and put it as input into any monotonic function, would the monotonic function change the maxima and minima of this function?
No.
No, because since it's monotonic, if it is monotonically increasing, then whatever the values of maxima and minima fx has, it will have the same maxima and minima. Because whenever
Yeah.
fx is increasing, it is also decreasing. Whenever fx is increasing, it is also increasing because of its monotonicity. And if it were a monotonically decreasing function, then the maxima and minima will be flipped. This maxima of fx would
Yeah.
be that function and vice versa. But if it were not monotonic, then some other maximum and minima could happen. So those things we have to take care. We cannot plug this into any non-monotonic function. So a good monotonic function that we can choose here is log x. Log x is always monotonic. See, take the first derivative of log x. It's 1 by x. And how do we know it's monotonic? 1
It
by
is
x.
decreasing because if x value increases, it decreases.
True.
So
So
log x will be decreasing.
log x will be, no, it's the derivative of log x is 1 by
Acha,
x.
हाँ.
And 1 by x, derivatives, what is the derivative test for monotonicity? We see whether this is always positive or always negative. And log x is only defined for x greater than 0. You have to remember that. For x less than 0, there is no log x. And for x greater than 0, see 1 by x is always positive. So this is a
Yeah.
monotonic increasing function. So log x looks like something like this is 1. 1. At 0, it tends to minus infinity. Fine. So we'll use log x. Could you mute? Because there's some from
Yeah,
your.
array, my like sister's going out back, so
Oh, I see. Okay. So we'll plug this into log x. Log of fx. So let's take a log on this side. So we get x log 1 by x. You know this property of log, that the power comes out and gets multiplied.
it comes forward.
True. And we can write 1 by x as x to the minus 1. So the minus 1 can also be brought out. So minus x log x. Now you do the usual things. You find the maximum minimum of this function, and this will have to match the maximum minimum of the original function. So you take a derivative of this new function, say this is gx. So g prime x is minus 1 log x using the uv multiplication rule, minus x, derivative of log x is 1 by x. So you put this equal to 0. The first derivative goes to 0, you get the points of extrema. So this one is minus log x minus 1 equals to 0, or log x equals to minus 1. X equals to, where is log x equals to minus 1? Okay, so good way to do this is take both sides as powers of e. So e to the log x equals to e to the minus 1. And now we know e to the something log, the something here comes, so x. So e to the log x equals to x. Where does it come from? It follows from the definition of log itself. What is log? Log asks the question, you have a base here which we do not usually write, which is e, the number e. So it asks the question, what power of e is x? What power should I put on top of e so that I get x? So that's what log returns, the power that you put on e to get x. So if you put that power on e, what do you get? You get x. That is the definition of log. So that's where it comes from. So you get x equals to e to the minus 1. Usually it's to the base e, log is usually to the base e, but sometimes it's to the base 10 also. Then we actually write it out. If it's 10, you have to write it out like this. Could be base anything, in fact, but usually these two are used. So you get my x. So x equals to e to the power minus 1, which means 1 by e. So there's something going on there at this point. Let's see what's going on. Take the second derivative, g prime of x, g double prime of x. So g prime was this thing, minus log x minus 1. Take another derivative, it becomes minus 1 by x. And you put in the value of this x equals to 1 by e. So you get minus 1 by e, which is minus e. Now, as you know, e is a positive number. E almost has the value 2.7. It's a positive number. So minus e is a negative number, which means we have got a maxima.
Yeah.
Maxima at x equals to 1 by e. So how does this function look like? Let's see. So at 1 by e, we should have a maxima. Some values we know the value of this function. Function was y equals to 1 by x whole to the x. At x equals to 1, this function should exactly be 1. So at x equals to 1, this function is 1. At 1 by e, it has got a maxima. And what about very close to 0? What value does this function have?
1 by minus e.
1 by minus e. Very close to 0? How come?
Acha, no, it will be 1 by e only, very close to 0 it is.
At 1 by e, it's got a maximum. We found that out.
Okay, so close to 0 e or minus e?
What I'm asking is limit x tends
X
to 0,
tends to 0. Okay.
1 by x whole to the x. What is this value?
X whole to x is, wait. I'm not getting answer, yeah.
Okay. How do you do these things?
We'll differentiate it, like we'll take the value of e to the power e, so it will, when we'll differentiate, we'll get it e minus e for the limiting value.
Right.
Then after that, I did not get what to do. That's why I was stuck here.
So once you took the log of this function, we had this
Yeah.
function minus
Oh,
x,
yeah, yeah.
right? So we can take a limit of this function and see what the value.
Yes.
So as x tends to 0, this function goes to
Minus x log x.
limit x tends to 0. So now x goes to 0, but log x, this thing, this goes to minus infinity. So how
Okay,
do
okay.
we do such things? We take another derivative. We know the L'Hopital rule.
Yeah, L'Hopital rule, yeah. We can differentiate it first, then we can take the derivative. We'll derive it and then we'll take it differentiation.
Yes. So if log x goes to 0, so I can write something like this, log x by 1 by x. So we have got this infinity by infinity form now. Both of them go to infinity. So we take a derivative of both top and bottom.
Yeah, okay.
Log x derivative is 1 by x. And 1 by x derivative is minus 1 by x squared. So x goes up, x squared by x, which is just x.
So x tends to 0 will be x only for x tends to 0.
This is 0 then.
Ah, okay, yeah.
So the log of this function, this goes to 0. So what does the function go to? At what value of the function is the log of it 0?
It is to the power like for log, right?
So I'm saying that log x equals to 0. So what is x?
0 to the power x.
Uh, how do you solve these equations?
We'll take the anti-log of here.
We take the antilog.
Yeah.
Is antilog of 0?
0.
No. Antilog of 0 is 1.
Okay, it's 1, okay.
It's 1. So like I said, you take e to the power log x on both sides equals to e to the
Yeah.
power. So e to the power log x is x, like we showed from the
Oh,
definition.
yeah.
This is exactly the antilog. So
Okay,
x
okay.
equals to e to the 0. Something to the 0 is 1. So
Yeah.
x to 1. So that is the value the function tends to.
Okay.
We've got 1 at 1, we've got 1 at 0. So the function is
Okay.
like this.
Acha, okay, okay.
So it might seem tedious and besides the point to visualize the function here, but it'll come in handy when you try to solve difficult problems. You will see it's very useful if you can quickly develop a feel for the function. It's harder to go down.
We have to do different double differentiation here also, right? Again,
Yes.
yeah. So the points are minus 12 and 24
Minus 12, 24. How come?
because I did double differentiation, so it comes out to be 6x. So I
Hmm.
just inserted the value
Hmm.
between them in minus 2 and
Ah,
4.
I see. I see. I see. Yeah. So one of them is a minima, another is the maxima.
Yeah, so 24 is minima and minus 12 is maxima.
Right. So at what values do you have this minima and maxima? What values of x?
Minus 12, sorry, minus 12 and 24, yeah.
These are the values of f double prime, no?
Yeah, double prime x, yeah.
At what values of x?
Minus 2 and 4. This is given in
Minus.
the, yeah.
Oh no, you don't put those values in. You put the value where you get f prime x equals to 0.
At x prime x equals to 0.
Yes.
So it will be, wait, let me think.
You put this equal to 0. That gives you the values.
Okay. 1. X is coming out to be 1. Minus 1.
X squared is minus 1.
X
So what
square
is
is
it?
minus 1. Plus minus. X square is minus 1. It could be plus minus 1 only. Yeah.
Mm,
So minus 1 is iota, right? In the complex number
iota.
system.
Yes. So at no value.
That is, it is not a value, means it is a irrational number, right? So we cannot say that it is a actually a point where it can be minus 1, 0.
Exactly.
Yeah, so it is a undefined value.
Undefined. Yeah. So there
Okay.
is no real X.
Yeah, there is no real value of x because
This is
minus
not.
root over minus 1 is not possible to have that.
Exactly. So what do you do here?
So we then I guess um we will do the differentiation of it and then we'll say at 0.
But we couldn't find the values where.
Acha, we cannot find. So it
But
is
we,
a undefined value. So the graph will be like graph will
so the
not be at
derivatives won't be helping you here. Derivative
derivation will not cannot be possible here.
does not come in handy.
Yeah, yeah.
So now your graph drag skills will come in handy. So you go from -2 to +4. -2 to +4. This is your range in which you have to find the minima and maxima of this function. And this function is a cubic function, x cube plus 3x. So near 0,
Yes.
it will look like 3x. And far from 0, it will look like x cube. X cube goes like this. All right. So as you can see, there are no points where the derivative is 0 for this function. So your local maxima and local minima, clearly you can see within this range. At -2, you've got this minimum value, and at +4, you'll get the maximum value within this range. So exactly the value of the function at -2 is the minimum value within this range. Because it's a
Yeah.
monotonically increasing function, it
Yes,
has to be
yes.
so. So you just do that. You put in the value. Also, without drawing a graph, you can say, because f prime x, see, this is always positive. It's a square number plus 3, another positive number. So this is positive, which means it's a monotonically increasing function. That means the lower limit will give you the minimum value, upper limit will give you the maximum value. So f min will happen at x equals to -2, -2 whole cube plus 3 into -2. This is -8, -6, so -14. And if max, this will happen as +4. Sorry, 76. Okay? So you get this value of minimum, you get this value of maximum. Fine? So this was again a different type.
Yes.
Okay, look at this. Now fx has these two different functional forms in two different ranges. These are called piecewise defined functions. And here you have to find which of these statements is true. Would you like to give it a try?
We will yeah, so we can first for the value which is between minus 1 and 2, we'll check for the x value. Means in the question, if x which value matches with the condition given, and accordingly we'll do the operation on it.
True.
Yeah.
So first one tells me fx is increasing on -1 to 2.
My
So what
if that
condition will be satisfied if fx is increasing?
so the first one, which is x is greater than equal to -1 and less than equal to -2.
Not only that, if it is increasing, f prime x has to be positive semi-definite, which means it
Yeah.
can be 0 or greater than 0.
Yes.
Hmm. So that condition has to be satisfied.
Yeah.
So let us see if that is satisfied. Within that range, the definition of fx is the top one, x 3x squared plus 12x minus 1. This is my definition within this range.
Yeah.
So you take f prime and see if this is positive semi-definite. So 6x plus 12. So at -1, what is the value? -6 plus 12. This is positive. And
Yeah.
at the
It's
other,
positive.
so this is obviously an increasing function. The slope of this line is increasing. Slope is 6. So if the minimum value is positive, other values have to be positive. Since because it's an increasing function, slope is positive for this line. So it's positive, which means yes, this is correct. First option is.
Yes.
What about the other options? If x is continuous,
Again we'll differentiate it. So 6x plus 12.
hmm,
So it will be at -1. It is for -1 it is increasing, and for 2 and for 3, it is also like it is a continuous function.
how do you know? What
We
is the
inserted the value again.
what is the condition for continuity?
Acha, LHS equals to right hand derivative equals to left hand derivative.
No, that's differentiability. Continuity is just the limit of this function.
Acha, limit of the function.
Limit, yeah.
Right hand limit should be equal to left hand limit.
Right hand limit equals to left hand limit equals to value of function at that
F of x, yeah.
value of function. So the value of function at
F of
that
x
point
of -1 and 3 we have to put right here.
at x equals to 2.
At x equals to 2.
That is the only point where it can be like discontinuous, because that's the point where you change the definition of the function.
Yeah. At x equals to 2, then you have to, you have to take the first equation only.
Exactly. So
So it is not continuous because f equals to 2, it comes out to be uh for fx, no wait, it comes out to be 60. No, for at 2, right? So 35, yeah.
35.
Yeah, 35 it comes out to be 35. And for -1 it comes out to be 6 as we did it earlier.
No, -1, not -1.
Okay.
See,
I have to
you've
take
got
2 here,
this
okay.
two definitions at x equals to 2. So the left hand limit, you'll have to take this because
Uh,
you're approaching from the negative side.
yeah.
Lower part. Lower part is defined using this part.
Yeah.
The upper part is defined using this part.
Okay. Achha, so I have to take the concept of continuity and differentiability over here.
Yes.
Okay. It's like all chapters are a little bit mixed over here in this
Yes.
question.
Yes. So you go from the right hand side. What do you get? 37 minus 2. This is again 35. And the value of the function at this point, this will always satisfy this value of the function because it's less than equal to, which means that at 2 the function is defined by this function. So it's 3 into f of 2 is 3 into 4 plus 12 into 2 minus 1. So it's again 35. So you see it's continuous. So this is also true. So these were like the multiple correct answer questions. You had these in IIT. You still have it, I think.
Oh. Then because I thought in IIT there would be like trickier questions like for you have to do the function trigonometric, then all chapters you have to mix up and then you have to revise them.
Yes.
Okay, okay.
Yeah, they'll mix up chapters for you. So you
Like in this one, they use continuity also and the function of limits and derivatives also.
yes. What about the third option? They say f prime x does not exist at x equals to 2. Now this is the concept of differentiability.
Yeah, then you have to find the first derivative and then x equals to 2 plus and 2 minus.
Exactly. Can you do that for me?
Yeah, yeah. So in this you have to take the first equation 3x square plus 12x minus 1 because x equals to 2 equal to 2. So this equation satisfies this one condition.
Left hand derivative. Yeah.
Left hand derivative. So left hand derivative will apply the limit 2 minus over here.
Mm.
So it will come 6 to the 12 plus 12 plus 24.
24. Let's see. So this is left hand derivative. Limit x tends to 2 minus f prime of x. And f prime of x is 3 to the 6x plus 12. 12 plus 12, it's 24. Good. What about the right hand one?
Right hand limit then 2 minus which will be
So
2
right hand,
2 plus sorry, which will be 37 minus 2 which is 35, which is not existing because both are different values.
right. So this right hand side, you have to take derivative one first.
Yeah, which is 37
0
only.
minus 1. No, you take the
Acha,
derivative of
हाँ,
that.
x minus 1, yeah. 37 minus 1, which is minus 1.
Yeah, f prime of x limit extends to 2 plus. It's just 2 plus minus 1. So this is just minus 1. Of course, they do not match, so derivative does not exist. So this is wrong.
Yes,
Oh no, so this is correct. So they actually say that the derivative does not exist. So yeah, this is correct.
it's correct because 24 and minus 1, two different values.
Hmm. And what about the last one?
Fx has maximum value at 2. So I have to find the maximum value, I have to prove it.
You have to show that this
Which
is
is
true.
show, okay. At x equals to 2, so the same equation you have to take. So it will be 3 into 2 whole square plus 12 into 2 minus 1,
Hmm.
which is 35 maximum value.
Right?
But that will be a minimum, right? Because it is minimal that will be.
Wait. What is your first criteria for finding the extremum? You take the first derivative and set it equal to 0.
Yeah,
You solve for x. Your x
yeah,
tells you whether it's maximum or minimum.
yeah,
But it could be that since the definition of this function changes, you've got a point where it is not differentiable. You
yeah,
already know that it's not differentiable at f prime x equals to x equals to 2. So
yes,
at those points, your test will not work for
yeah,
from for derivative test. So at those points, you have to check explicitly. Remember last time we had seen that there could be these points on a function where it's not derivatives do not exist. See these points, kinks. So you've got a kink here. At this
huh.
point, the test will not work. So you have to check for those explicitly.
Okay, yeah,
If
got
those
it, got
points
it.
have greater value than any other point.
Huh.
So as you can immediately see that the function on the left hand side is increasing function. How
Yes,
you take a first derivative and you see it's always positive. What's the first derivative? It's 6x plus
6x
12.
plus 12.
So it's a increasing function.
Yes,
Whereas this one, the first derivative of this is minus 1. So this is
huh.
a decreasing function
Yes,
and it's continuous. So it was increasing and now it is decreasing. So there
yes,
has to be a maximum value at x
yeah.
equal to
So at
6.
minus 1, you have to put the value of x.
Yes. So this is also correct.
Huh. So that we have to equate it at x f of f prime x equals to minus 1.
Right.
So x6x plus 12 equals to -1.
Hmm? No, you don't have to find the value, but you
Okay.
just have to verify
Prove
whether
it.
it is
Okay.
correct. Whether this is correct, you have to,
Okay. Okay.
because it's just options, right? You have to
Ah,
check
yeah,
which
yeah.
of the options is correct.
So all of them are correct.
All of them are correct. Yes.
Acha. All okay. All of the above.
Yes. In the range 0 to pi by 2.
Yes. So first we'll do, find the f prime and we'll equate it to 0. F prime equals to 0.
Right.
So to be cos x minus 1.
Cos x minus 1.
So cos x minus 1 equals to 0. Cos equals to 1.
Yes.
So cos x equals to 1. So cos x equals to 0.
X
X
equals to
equals
0.
to 0. So
Wait,
it is maximized x equals to 0.
wait. You don't know whether it's maximum. Can you
I
take
have to
the
again, then I have to again derivative. Like take the second derivative.
yes.
So cos x minus 1, it will be sin x minus sin x
Minus sin x.
minus sin x equals to 0. Acha, minus sin x, sorry.
Just minus sin x. F double prime x
Equals to minus sin x.
minus sin x. And you put in this value here.
So sin 0 is 0 minus. So it is a
You don't
constant function, right? 0.
you don't know as of yet.
Because 0 has no
Because with
sign, so it will
0,
be,
you have to keep on taking derivatives unless you get a non-zero value.
yeah, non-zero. So again, it cos 0, again I have to do f3x.
Yes.
So it will be cos x
Minus.
minus cos x. It
And
is
then
now
you put,
minus 1, uh, which is the this value, minima value, maximum value.
so you get minus 1.
Minus 1, which is the maxima value.
But see, this 3 here,
Yeah,
is it odd or even?
odd.
What happened if it was odd?
It would not matter if it is a positive or negative. So it is a minima value, maximum value only.
No, it's a inflection point.
Achha, it's an inflection one. Yeah, yeah.
It's an
Sorry, I
inflection
got
point.
confused between that. Okay, yeah. It's a inflection value.
It's an inflection point. So all this exercise has not given you any maxima or minima. That's
So
usually how IIT JEE questions come. That your usual techniques will not work,
yeah, I
and
had to
then you
just
have to see
I had to go through
whether
a different way, mend our ways in a little crooked way.
yes. So now
Okay.
you have to see whether this function is increasing or decreasing. If it is an increasing function, you can immediately say the lower limit will have the minimum value, upper limit
Yeah,
will have maximum.
maximum value.
So let's see whether it's increasing or decreasing.
Yeah.
How do you see if it's increasing? You take the first derivative, it's cos x minus 1. You see what the sign of this is, whether it's positive or negative in this range from 0 to pi by 2. Cos x within 0 to pi by 2, it's always some value from 0 to 1. Cos x goes like this from 0 to pi by 2. At pi by 2 it's 0, at 0 it's 1. So it's always some value from 0 to 1. So see, at the top first value this is 0, but then it keeps decreasing. The value of this function keeps decreasing and it's always negative. So it's negative semi-definite. You call this a negative semi-definite. This is less than or equal to 0, which means it's a decreasing function. No,
Yes.
f prime x is always less than equal to 0. It's a decreasing function,
Is a decreasing function.
which means that first point gives you the maximum value and the last point gives you the minimum value since it's decreasing. That's how you say that f of the first point 0, this is my maximum value. So sine 0 minus 0, which is 0. This is my maximum. and minimum is at the last point, pi by 2. So sine pi by 2 minus 1, which is, what is sine pi by 2? 0 minus 1. Sorry, it's 1. Sorry, what am I doing? You have to put in pi by 2 in both values, no? Not 1 here. So the function is sine x minus x. So you put in sine pi by 2 minus pi by 2. This is 1 minus pi by 2. Pi by 2 is greater than 1. Pi is greater than 3. So this is greater than 1.5. So you get a negative value. So this is your minimum value. Maximum value is 1. Is 0. So the maximum and minimum local values are 0 and 1 minus pi by 2. Are you there? Can you hear me?
Yeah, sir. I have joined through mobile now.
Oh,
Yeah, because my like the network is so much fluctuating in laptop, so I like switched off my laptop. So I will like now I am using the data mobile data now.
so is there a problem there today? Something happened?
Yeah, I don't know. Like there is a it's showing low connectivity. So I'll ask my father to like fix it again once. I guess the bandwidth is low today.
Oh,
Yeah, I'll check it once. I'll then mend it by today.
okay. What companies do you guys have there for
Geo,
broadband?
Geo,
Geo.
Geo. Yeah.
Geo.
I don't know, like bandwidth is going low and not sure why. I guess but I'm in the last room, right? So the distance is very much,
Oh, I
and
get.
and all the guests were stand there, like my sister and they all are like us
There
outside.
are
So like,
people today.
yeah, there are people to decide. I could not go outside. Like it will be a disturbance.
Okay,
Yeah.
it's fine. Okay, so you see the
Yeah.
maximum value turned out to be 0, minimum value turned out to
Yeah.
be
Yeah.
1 minus pi by 2.
Yeah.
We have to do something unusual to get these values. No, you have to see that
Yeah.
the decreasing function and then you take the limiting values.
Yes.
So let's see what we can do about this. X minus 1 to the 4. So calculation is very easy. F prime x is
X minus 1 to the 4, right? It is
4x minus 1. Okay,
minus 1, 3.
this one. So you put this equal to 0. What do you get
Yeah,
out? You
it
get
will be x minus 1, x equals to 1.
x equals to 1. So you have to check at
Yeah,
this point. So
yeah,
check, we take the second derivative. Second derivative is also easy to calculate. It's 12 x minus 1.
12 x minus 1
You put in this value here,
to
x
the
equals
power
to
2, x minus 1 whole square.
x minus 1 whole square. True. You put in this value, what you get is 0.
0.
So you again do the third one
Yeah,
and you get 24 x minus 1. Again you get 0.
yes, it is 0. So it is a inflection, right? Inflection point.
So you keep doing as long as you don't get a non-zero value. So if 4
Yeah,
is,
24 now,
finally you get 24. This is positive.
which is
And
a minima point.
yes, so this is a minima point
Or,
because
or
4
is a
are
even value.
even value. So
Yeah,
this is, we get a minimum
yeah.
at x equals to 1. It says discuss the function and plot the graph.
So again, we'll do the derivation until we get a non-zero value.
Hmm. We'll do that.
So first will be 6x to the power 5 minus 12x cube plus 6x.
But before that, let us see if we can simplify this a bit. This looks
We
very
can
much
take,
like whole
yeah,
cube
we can
formula, right?
we can assume whole cube as sorry, x square as y or something, so that we can take
Yeah.
the factors.
So x squared whole cube minus 3
3x square into the power 2
plus 3,
plus 3x square plus
and then
minus 5.
we need a minus 1. So we have minus 4 remaining.
Yeah.
So we get x squared minus 1 whole cube
Huh.
minus.
Minus 4.
We did this because now it's very easy to take a derivative.
Yeah. 3, it will be 3x square minus 1 to the power 2 minus 0. It is same.
Yes. 3 x squared minus 1 whole square. Now you have to use the chain rule because this thing is not x.
Yeah.
So you take a
So
derivative of this
2x, it will
2x.
be 2x.
And you see where the maximum minima occur. Put
It
it
will
equal to
be
0.
it will be 1 only. Again.
So you get two different answers. See, at x equals to 0 and x equals to 1. There are two factors. So x equals to 0
and x equals to 1
and plus minus 1 because
plus
this is
9.
squared. So
Yeah, yeah, yeah.
now you take a second derivative to see which of these are is which. And
Yes.
derivative is
Here you have to apply the product rule here again.
product rule. 6x squared minus 1 into 2x
Into
plus
2x plus 2x, 3x, 3 into x square minus 1 to the power 2 into 2, which
into,
is 6.
yes. And you
We
put
can
in
take
these
this common again.
three values. All of these three values we'll have to put in. So let's
Yeah.
see f double prime of minus 1. What is it?
Minus 1 will be high. So it will be 0.
6, then 0. Yeah, first term is 0.
Yeah. The second term is also 0.
Second term is also 0. So this is exactly 0.
Huh.
So
Even at 1, it will be 0.
looks like we'll have to take another derivative.
Yeah.
And what about at
And
0?
at 0, it will be 12x plus 3 to the 6.
At
No,
0 it
sorry.
will be
12x. It will be minus 12x minus 6.
it. First term is 0, no? You put in 0 here, there's a 2x here.
Acha, 2x. I didn't see 2x. Yeah. So it will be minus 3, minus 6. Minus 6.
plus 3 into 0 minus 1 whole square into 2.
Into 2.
Shouldn't
6.
rush. Yeah, shouldn't rush to the calculation.
Yeah.
So this one, you know, this is a minima at x equals to 0.
At x equals to 0, it is the minimum value.
But at the other 2 points, you have to investigate further.
Yeah, you have to then again derivate it.
Yes. And what would that be? F triple prime x. Again, use the chain rule. So 2,
Yeah.
let's do the first
2
function.
into 6
6 x square minus 1 into
cross
2x
this.
into 2x
Yeah.
plus
2. It will be 6 into x square minus 1 into 2.
plus 6 into
Again, chain rule.
2. Yes, x square minus 1 into 2x.
Yes.
So let's see if we can simplify this a bit. 6 4s are 24 x squared minus 1 plus 12 x squared minus 2. Where did you get this x squared minus 2? There should be 1, no? X squared minus 1.
Yeah. I said one only.
Yes. And then we got 24 x into x squared minus 1. And
We
now we
can
can
take 12.
put in these
12x
values.
common.
We can take 12 common, that's true.
But nothing will, there will be no effect or such on it.
Right. So we can just put in the
We'll
value.
put it, we'll put 0 right here.
0 is done. Only the plus 1 minus 1 remain. 0 we
Okay,
know.
yeah.
So
अच्छा हाँ plus minus yeah.
what about minus 1?
24 into 0 again. 20.
Into 0 plus 0
12 into
plus 0.
plus
All
0.
zeros.
Just 0 again.
Again 0. So we might have to take another derivative. Also at plus 1 it will be 0.
Yeah.
So another derivative has to be taken.
Yes.
Before that, let us try to simplify this a bit. So f3, this turned out to be, we take this
It's a
12 out.
very long process, a very tedious one.
Yes, this one turned out to be tedious.
Yeah.
Yeah, usually in IIT JEE, if you get a problem like this, you look at it for a few minutes and then you leave it and go to the next one. Because this is not worth
Okay.
this amount of time. You could do two different problems.
Yeah. It is almost taken 10 minutes for us.
Yes. Take x squared minus 1 common, and then you have 2x squared plus 12 plus 24x. Sorry, 12 is common already. So you have 2x squared plus 1 plus 2x. Something like this. Now you take another derivative. You don't even need to do this because this will give you 0 if you put in plus minus 1. So only this part will count. Sorry. So f4 plus minus 1 equals to 12 into 2 into plus minus 1. 1 squared is 1 plus
1 plus 1 full square.
it could either be 2 squared or it could be 0 squared.
Yeah.
Plus 2 minus 1 is 0.
Yeah.
So 2 squared is 4.
Yes.
This is for the plus 1. So 24 into 5. And the other case is 12 into 2 into minus 1 into 1.
Yes.
So it's 20 minus 24. So you finally get positive and negative value. Don't
Yeah.
even do this because it's positive. You can see just
Yeah.
the plus 1, positive 1 turned out to be minima, and
Minima
negative
and
one
minus one turns out to
maximum.
be maximum.
Okay. Okay, since this chapter is done now, application of derivatives, um, when can you give a test on this?
Next Saturday.
Next Saturday. Okay.
Yeah.
You
I
have
would
it
need one for like,
every
revision, right?
for,
That's why. The date on Saturday.
yeah, on Saturday we'll have the
Huh?
have the exam,
Hi.
but from 8:30.